Hi everyone. In this video, we're going to do 4 more examples of adding and subtracting rational expressions with different denominators. And these new examples in this video are going to be slightly more challenging. Our first example is to subtract these two fractions. Remember that you have to have common denominators before you subtract fractions. What I would do first is factor this second fraction's denominator. X squared minus 4 factors to be x minus 2 times x plus 2. It's a difference of squares. Then we need to find the least common denominator. Both fractions have one copy of an x minus 2 factor, so which one has more? Well, they have the same amount of x minus 2's, so we need one x minus 2 as part of your LCD. The second fraction has an x plus 2. The first fraction does not. Which one has more? The second fraction does, so we need the more as part of your LCD. So we'll want to be subtracting two fractions, both of which have the LCD. Right now, the first fraction only has an x minus 2. What is it missing from the LCD? It's missing the x plus 2, so multiply the top and the bottom of the first fraction by x plus 2. When you distribute the 4, you end up with 4x plus 8 as the numerator of the first fraction. The second fraction already has the correct LCD, so you don't have to do anything with the numerator. And now that these two fractions have the same LCD, which is good, we can actually subtract the fractions and keep the bottom the same. Subtract on top, and we have 4x plus 8 minus 16. Combine like terms to get 4x minus 8 over your denominator of x minus 2 times x plus 2. But don't stop yet, because we can still do something with the top. On top, we can factor out a GCF. The greatest common factor on top is a 4, so when we factor out a 4, we're left with x minus 2. And oh look, what happens? You can cancel the x minus 2's, which gives you a final answer of 4 over x plus 2. Be careful, don't divide 4 and 2, because 2 is a term, not a factor. Okay, let's go do another example. Notice that this one was different because we had this last step. We had to factor and cancel. We didn't have to do any of that in the previous video. Now we're going to add two fractions. Here, the LCD is a little bit more straightforward. Your LCD is going to be 3 times x minus 3. What is the first fraction missing from the LCD? Well, the first fraction has the x minus 3, but it's missing the 3, so multiply the top and the bottom of the first fraction by 3. The second fraction has the 3, but it's missing the x minus 3, so multiply the top and the bottom of the second fraction by x minus 3. For the top of the first fraction, 3 times negative 2x is negative 6x. And for the top of the second fraction, you're going to have to FOIL. X times x is x squared. X times -3 is -3x. 4 times x is plus 4x. 4 times -3 is minus 12. Now we can combine like terms in the numerator and keep the bottom the same. We have an x squared. And then we can combine several terms. We can combine a -6x plus -3x plus 4x. Combine all of those, and we get -5x. Then we have the minus 12. You should probably check to see if the top factors. Are there any numbers which multiply to -12, which also add up to -5? Well, no, which means the top does not factor, so you are done. This problem was a little bit different because we had to FOIL after we got the least common denominator. Another question, pretty important one here. First, let's factor the first denominator. M squared minus 100 is a difference of squares, which factors to m minus 10 times m plus 10. Then, to find the LCD, we want to have a 2, because the second fraction has a 2. We need an m minus 10, because the first fraction has more m minus 10s. And we need a single m plus 10, because both fractions have a single m plus 10 in the denominator. So we want to add two fractions, both of which have the LCD. What is the first denominator missing from the LCD? It's missing a 2. So multiply the top and the bottom of the first fraction by 2, which will give you 180 as your numerator. What's the second fraction missing from the LCD? The second fraction is missing the m minus 10. So we want to multiply the top and the bottom of the second fraction by m minus 10. Distribute the 9 to get 9m minus 90. Now that we have common denominators, add the fractions. In the numerator, 180 plus -90 is going to be a positive 90, and we have a 9m. The denominator stays the same. Are we done? No, not quite, because we have a GCF for the numerator, which is 9. Factor out the GCF of 9, and we're left with m plus 10. And look what happens. The m plus 10s cancel, giving you a final answer of 9/2 times m minus 10. Okay, we've got one more example. This one, we have to factor both denominators to start. For the first denominator, you want to find two numbers which multiply to equal -6 and which add up to equal -1. Those numbers are going to be a -3 and a +2. Since the trinomial starts with a 1, you can go straight to your parentheses and get x minus 3 times x plus 2. For the second fraction, you want to find two numbers that when you multiply them give you 6, and when you add them give you 5. Those numbers are a +2 and a +3. Since the trinomial starts with 1, you can go straight to your parentheses and get x plus 2 times x plus 3. I'm just going to scribble out the denominators here because we factored them and they look different now. So look at the first fraction and the second fraction's denominator and find the LCD. Both fractions have a single x plus 2, so we need an x plus 2. The first fraction has a single x minus 3, so we need an x minus 3. And the second fraction has an x plus 3, so we need an x plus 3 as your LCD. Write two fractions, both of which have the LCD. And notice that the first fraction is missing an x minus 2. Sorry, first fraction is missing an x plus 3. So multiply the top and the bottom of the first fraction by x plus 3. The second fraction has an x plus 2 and an x plus 3. It's missing the x minus 3. So multiply the top and the bottom of the second fraction by x minus 3. Then distribute your numerators. Now that you have common denominators, we can combine these into one fraction with that common denominator. When you subtract, remember to distribute the negative to both terms of the second fraction. So we really have a negative x squared to begin with. And when we combine a 4x minus a negative 3x, that's really 4x plus 3x, which is a plus 7x. Then we have a plus 12. Next thing I would do is factor a GCF of -1 out of the numerator. Just going to change all of your signs. Also makes you have a +1 in front of the x squared, which is going to be easier for factoring, if we can factor. Are we done? Maybe. We should try to factor this trinomial on top. Look for two numbers which multiply to equal -12 and add up to equal -7. You might think -3 and -4 because those do multiply to 12 and they do add up to -7, but they don't multiply to -12. So that doesn't work. And in fact, we are done because the top does not factor. And that's all I have for this video. Hope you learned something. Have a good day. Bye.